All right, let's get right into it. Today, we're diving into a highly visionary explainer detailing the quantum fractal ecosystem. What we are looking at is a completely revolutionary nanofabrication blueprint conceptualized by Lázaro López Paz and the AI Grok over in Barcelona and slated for realization in 2026. Now, if you are a chief researcher, a nanofabrication engineer, or an international tech investor, you'll want to consider this your master technical manual. We are talking about a radical ground-up shift in how we approach materials, energy, and massive data deployment.
Here is our roadmap for this explainer. We'll start with the visionary blueprint, dig into the underlying physics and mathematics, and then explore the 4 core pillars of nanofabrication. After that, we'll cover the critical materials and the strict safety assembly protocols required, move into 4D digital twin validation using Unreal Engine 6, and wrap up by evaluating the commercial viability for global 6G and 7G networks.
Okay, kicking things off with Section 1, the visionary blueprint.
So, going back to Barcelona 2026, I want to be clear. This isn't just theory anymore. It is a paradigm-shifting infrastructure blueprint designed specifically for elite engineering research teams and forward-thinking tech investors. We're talking about merging macroscopic geometric patterns directly with atomic-level quantum mechanics. And what's really fascinating here is the historical evolution of cymatics. Historically, cymatics was just the visual study of sound waves bouncing on a surface, right? But here, we are taking that evolution, specifically using geometric patterns inspired by crop circles, and applying it as the foundational architecture for physical metamaterials. We are using these very specific geometries to fundamentally revolutionize processing power, ambient energy harvesting, and the absolute stability of future 6G and 7G networks.
Moving on to Section 2, physics and mathematics. You know, to truly grasp the commercial and technical power of this ecosystem, we first need to demystify the core physics that make the whole thing tick. We have to look at how sound, light, and geometry interact at the nanoscale. The crucial takeaway here is that we are literally encoding harmonic sound and light wave patterns directly into physical matter. By engineering these phononic crystals with specific cymatic geometries, we're able to create these ultra-wide band gaps. And this is a massive breakthrough, because these band gaps effectively block out thermal noise. It creates this perfectly isolated environment where delicate quantum states can actually survive, completely eliminating the need for those massive, traditional cryogenic cooling systems we're used to seeing.
And this brings us beautifully to our solution for quantum stability, the inverse Purcell effect. By deliberately designing our fractal cavities at a sub-wavelength scale, we achieve what's known as strong coupling. This fundamentally optimizes the spontaneous emission rate of photons, which prevents quantum decoherence. Simply put, we are keeping our quantum information completely stable and entangled by using the physical fractal shape of the cavity itself to control the photon's environment. It's incredibly elegant.
Which leads us right into Section 3, the 4 pillars of nanofabrication. Listen, for you nanofabrication engineers out there, these are your primary targets. These 4 revolutionary devices make up the core architecture of the entire ecosystem. First up, the Cyma quantum resonator is absolutely phenomenal. It uses precise diatonic ratios, specifically 1:1, 2:3, and 3:4. These ratios are literally carved into the notches to perfectly synchronize resonance nodes and optimize photon coherence. Next, we have the Aurea vortex harvester. This device maximizes the capture of ambient kinetic energy by utilizing physical Fibonacci logarithmic spirals, which ensures just incredible energy efficiency. And finally, the fractal graph metasurface integrates complex graph theory using Julia fractals to perform actual quantum computing right there on a flat, highly scalable chip. Now, look at this comparison when we apply this architecture to soft robotics. It's a real game changer. We are completely eliminating software vulnerability. The binary helix memory utilizes the mechanical coupling of Vitamer materials formed into a binary helix shape. By using auxetic geometries, which are materials that actually grow thicker when you stretch them, alongside those binary notches, we are physically programming memory into the structure of the material itself. This allows autonomous soft robots to change shape and react to their environment entirely through physical mechanics. Zero centralized software required.
All right, Section 4, critical materials and assembly. Of course, building these atomic-level structures requires a very specific matrix of next-generation materials, and I cannot stress this enough, completely uncompromising industrial safety protocols. We're talking about using lanthanides for quantum dot doping at a precise 0.1 to 0.5 mol%, and perovskites mapped at 20% efficiency for photovoltaic conversion. But listen, as a chief researcher or engineer, your team has to enforce rigorous contingency plans. We are dealing with highly reactive chemicals here. That means mandatory, strict toxic waste neutralization for those heavy metal lanthanides to meet current safety standards. And because we use liquid gallium for our high UV reflectivity plasmonic interfaces, alongside chemical vitrimers, you absolutely must have active, strict emergency liquid spill protocols in place. Proper biosecurity and toxic waste management are just as critical as the physics themselves.
So how do we actually put this together at the atomic level? The self-assembly follows these critical engineering steps. First, we define our hybrid lithography parameters to synthesize the vitrimer-based structures. Then we apply highly focused lasers as optical tweezers to map our nodes right into biopropart graph crop circle patterns. Third, we employ advanced ion etching to precisely carve those fractal circle patterns into the material. And finally, the 4D printing process takes over. This actually encodes the time variable, allowing the material to physically evolve its shape after manufacturing based on thermal stimuli.
Section 5. Unreal Engine 6 Digital Twins. Now, before a single atom is physically placed or a single chemical is mixed, elite engineers validate this entire mechanical and optical structure using digital simulation. By combining Unreal Engine 6's toolset, we create a flawless digital twin. We use Lumen to validate the physical propagation of those entangled photons inside our fractal cavities. Then, we configure nodes in the Niagara particle system to simulate incredibly complex light fields and photon behavior. Meanwhile, Nanite renders the exact microscopic geometry of billions, literally billions, of binary micronotches. Once it's all validated, we export those high-fidelity point clouds straight into CAD systems for perfectly precise 4D manufacturing. Finally, Section 6. Commercial viability and 6G deployment.
Let's step into the boardroom for a second. For the international tech investors and the chief researchers presenting to them, let's look at the hard performance metrics that make this a massively lucrative strategic asset. To successfully dominate the massive 6G and 7G global communications market, our engineered fractal cavities are designed to hit a very specific critical success metric, an orbital angular momentum, or OAM, mode purity greater than 95%. Hitting this metric guarantees the ultra-stable, massive bandwidth necessary to run next-generation networks without any signal degradation.
So what does that 95% purity actually get us? It translates to massive bandwidth scaling, allowing the multiplexing of 16 orthogonal states without any cross-interference. The economic return on investment here is simply staggering when you realize we are miniaturizing entire quantum computing components onto a single scalable chip. This technology will literally form the transformative, self-adaptive structural DNA of future smart cities. Ultimately, this highlights the immense strategic value of patent leadership. Whoever controls the disruptive patents for these fractal ecosystems ensures absolute dominance in global technological positioning.
I'll leave you with this provocative thought to wrap up our explainer. We've detailed the replication process for your research teams, the strict safety protocols, the mind-bending physics, and the immense commercial ROI. As we successfully merge somatics with quantum mechanics to physically program matter just like software, the true question isn't whether this is going to change the world. The question is, who will be the first to capitalize on it? Thanks for diving into this blueprint with me today.